This is how you test in the subsurface for gas and oil. As you can see, the electricity drives this motor over here. The motor turns this weight around. This is called a counterbalance. The counterbalance is attached to this lever, which goes up and down. The lever is attached to this large beam, which you call the walking beam. And notice how the walking beam goes up and down. The motion of the walking beam pulls this rod, which is called a sucker rod, up and down. This sucker rod goes all the way down to the reservoir, about 1,100 feet. Goes right down through what is called the tubing, which in turn is inside the casing. At the very bottom of this is a pump. The sucker rod activates the pump, and the pump pulls the oil up through the tubing and out here. Now, on some wells, you don't even have to have this surface completion unit. The oil flows to the surface by itself. That's relatively rare. You find that in less than 10% of the wells. But if you do have that, all you have to do is put a series of valves and gauges right up here, and this is called a Christmas tree. All you do is you regulate the flow to the surface. Either one of these completion techniques that you use, you then take the oil and you put it down through these pipes. And we'll show you where these pipes go. That pipeline, along with pipelines from other wells, comes into this unit, which is called a separator. Now, if you remember, when we were pumping the oil out of the ground, there's a lot of gas dissolved right within the oil. Not only that, we also pump up a lot of water along with the oil. This unit is designed to separate them. As you can see, it's very long and narrow, and that's why it's often called a gun barrel separator. It separates the gas, the oil, and the water on the basis of buoyancy or gravity. The gas at the top, the oil in the center, the water at the bottom. The water is then disposed of. The gas can be sent to market. And the oil is then sent through these pipes that you see right here and is collected in these tanks over here. These are called stock tanks. The oil comes in here. There it is. In a small field like this, a truck comes by periodically to pick up this oil. In a larger field, we actually have a pipeline going from these tanks to the refinery. Sometimes you can have a lot of oil below the surface of the ground in a reservoir, but you can't pump much to the surface because the rocks are relatively impermeable. The oil doesn't flow readily. There are ways of getting at this. We can artificially stimulate those reservoirs. Let's start with the chemicals first. What they do when they use chemicals is that they use two typical chemicals, a surfactant and a polymer. First, they inject a surfactant down into a well, and their surfactant looks like this. The surfactant is just a detergent, and a detergent is used to break down surface tension. And when this surfactant is injected into the reservoir rocks below the surface of the ground, it washes the oil off of them. So the purpose of the surfactant is to wash the oil off the pore spaces of the rock in the subsurface. Now, this is very, very expensive. Once some surfactant is injected into the ground, then you inject this second liquid, which is called a polymer. And this liquid is often called thick water. And in fact, if I shake this up, look at the bubbles in this. You can see how thick and viscous this water is. Now, this is cheaper than the surfactant. And the idea here is that you now put this thick water or polymer into the subsurface. It drives the surfactant ahead of it, and the surfactant washes the oil and drives the oil ahead of it into the adjacent producing well. It's a pipeline. And this is a major pipeline that goes from Houston, Texas, all the way to Chicago, Illinois. We're about halfway along it right now in Oklahoma. This particular pipeline carries not only crude oil, but also refined products such as gasoline, kerosene, and diesel fuel. How do they keep those products separated? Well, those products are called batches, and they'll send through a batch such as crude oil, and they'll separate it with one of these large rubber spheres, which is called a pig, and then they'll send through another batch. At regular intervals, along either a gas or a crude oil pipeline, you have to have compressor stations such as this. They keep the fluids moving. There's a compressor station about every 100 miles along this pipeline. And this pipeline, along with most other pipelines, is buried below the surface of the ground. It keeps it protected and out of the way. In the case of the Alaskan pipeline, which crossed the frozen Arctic tundra, they actually had to suspend it above the surface of the ground to protect the frozen ground from the hot oil which is flowing through the pipeline. When we take a look at a pipeline system, there are two parts to it. Smaller pipelines gather the oil from producing wells. This is called the gathering system. The oil, or the gas, is then put into a large pipeline, which takes it to a refinery or to a port. This is called the trunk line. Refining is a process in which crude oil is broken down into its valuable components. Refining has been known for mankind almost from its very beginning. This is an outcrop of asphalt. Actually, what we have here is an oil seep. Crude oil is seeping up from the subsurface, and especially on a hot day like this, the lighter fractions of the crude oil evaporate. This leaves behind the heavier fractions, such as this tar and asphalt. Indians used to know about this, and they sought out areas. They'd bring their canoes here to patch them up and weatherproof them. They had no use for the lighter fractions of crude oil, such as gasoline and kerosene. This is what was valuable to them, the tars and the asphalts. There's a modern refinery in the background, and many of the processes that are going on there are very similar to those which occur naturally on that asphalt seep. This is the very heart of the refinery here, the fractionating tower. And, in very simple terms, crude oil is put into the fractionating tower, and heat boils out different components or cuts at different temperatures. The shorter the hydrocarbon chain, the lower the temperature at which it boils off. For example, we already know that natural gas, carbon 1 through carbon 4 in size, is a gas under normal room temperatures. The shorter the chain, the lower the temperature at which it boils off. So as the crude oil is subject to the heat right there, different size molecules boil off at different temperatures at different areas of that fractionating tower. We can show you some of the different cuts that you get from crude oil. Our first cut is gasoline, composed of hydrocarbon molecules C6 through C10. This boils off at a very low temperature, anywhere from about 100 to 350 degrees Fahrenheit. Our second cut is kerosene. Kerosene has C11 through C12. And kerosene, of course, is used as both as a fuel and as a cracking stock. It boils off from about 350 to 440 degrees Fahrenheit. Our next cut is a light gas oil from C13 to C17. It's also used as cracking stock and as diesel fuel. It boils off anywhere from about 450 to about 550 degrees Fahrenheit. Next, we boil off the heavy gas oil, C18 through 25. This is used primarily as lubricants, and this boils off anywhere from 550 to 650 degrees. Finally, what we have left over is what we call residuum. and this is anywhere from C26 all the way up to C60. This is the least valuable product. It's used for waxes and for asphalt.